Okay, let's go ahead and get started. So, hello, folks. My name is Dr. Hansi Singh, and today at our weekly Planette webinar, welcome, we will be talking about how the ocean drives the weather. So, at these weekly webinars, we go over various factors driving the long-range weather outlook and how these factors might change your decision making as oh, excuse me, there's somebody in the waiting room. I'm trying to figure that out. Okay, there we go. Um, so as these factors impact your decision making from insurance to agriculture to finance to basically any environmentally vulnerable industry. So at today's webinar, we're specifically going to talk about how the ocean drives the long-range weather outlook because the ocean is really fundamental to being able to forecast weather beyond the next 7 days. So what we'll do is we'll look at the factors generally by which the ocean impacts the long range outlook. And then more specifically, we will look at the factors of the ocean that are driving that outlook today. And there's some really interesting things going on in the ocean, such as, wait for it, the Blob 2.0. So we will talk about the Blob 2.0 and we will talk about the really pindly La Nina-esque thing happening in the tropical Pacific. We'll even talk about the North Atlantic warming hole, which is sort of happening right now, which is indicative of a weakening AMOC. So really excited to go over all of these factors with you. So let's get started. Before we, dive right in, I just want to say a little something about who I am. I'm an Earth system scientist. I am CEO and co-founder of Planette AI. And I formerly worked for the Department of Energy. I used to be a professor. My co-founder, Dr. Ramea, and I, we began this company so that we specifically could bring the latest in weather research technologies from the research world to the real world to actually make a difference in real world decision making. So this is why we're here, and we're excited to be able to communicate some of this with you at today's webinar. So, how does long range weather forecasting work? Well, it fundamentally relies on the ocean. So the way that we do regular forecasting, basically your 7 day weather forecast is through an atmosphere only model. Now the atmosphere is pretty mercurial. It forgets where it started from about a week or two, in time. So that means that if you have only an atmosphere model, you can at most predict a couple of weeks into the future. In order to do anything beyond those couple of weeks, we really need a much more complex modeling framework. This is where Earth system models come in, and oceans are such a critical component of those Earth system models, as we'll see today when we look at the factors of how the ocean drives the weather. And in terms of these Earth system models, please keep in mind that when we do these long range forecasts, we cannot predict day to day, but we can predict week to week for a while, then month to month, then season to season, and get some really good insights on what to expect over the next few months for the purposes of decision making across many different industries. So, today, what we'll go over, first of all, is why the ocean is such a powerful player in the weather. Then we'll talk about El Nino and La Nina, specifically what's going on in the tropical Pacific and why that's so important. Then we'll talk about the blob, including potentially the blob 2.0 and other just large scale kind of temperature deviations in the ocean and how those drive the weather. And then we'll talk briefly about the AMOC of the day after tomorrow fame. And then we will also just give a quick forecast retrospective on what's going on today over South Asia, which is not good, but it was forecasted. And so just wanted to provide a quick review of that and why, when we were predicting this about 4 weeks ago, we really believed that it was a very robust forecast. And in fact, we presented it at a webinar several weeks back. So to begin, why is the ocean critical? The ocean is critical, first of all, because it has a huge thermal heat capacity. It stores a ton of heat, it releases a ton of heat. You can basically think of it as, the atmosphere is the flywheel, the ocean is the brake of the climate system. It has a huge amount of thermal inertia. And not only does the ocean hold this heat, but it moves this heat around. That's what the AMOC does. It's a huge conveyor of heat, of water and warm water specifically towards the pole and therefore heat. And then finally, the ocean has temperature patterns. If those temperature patterns are unusual, they can trigger changes in the atmospheric circulation. And those atmospheric circulation changes impact temperature, precipitation around the world. And sometimes the effects that you see on the atmospheric circulation, they can be pretty far away from the location of that ocean temperature anomaly. And so, when those impacts are far away, we call those teleconnections because they really have to do with waves in the atmosphere and ocean. These very large scale waves, not the usual surface water waves that most of us think of when we think of waves. And these giant planetary scale waves are what transmit the information from where that ocean anomaly is to the rest of the planet. So I want to begin by just saying a quick word about El Nino and La Nina, and specifically the El Nino Southern Oscillation, known as ENSO. So what is ENSO? Most of us, have a sense of what it is. It is basically a planetary scale anomaly in temperature over the tropical Pacific. And as we mentioned earlier, whenever you have these kind of unusual temperature anomalies, you end up with these major impacts on the atmospheric circulation that then change the weather over very different, far removed parts of the world. This is why, what goes on in the Pacific is so important for the rest of the globe. Note that these anomalies here, they're gigantic. The Pacific is basically half the planet. And so, the size of this anomaly is like 10,000 miles, right? It's a huge anomaly of heat. And it just, creates signals all over the globe. What causes El Nino and La Nina? Basically, it's caused by interactions between the trade winds and the subsurface ocean. There's a bunch of different waves that move energy and basically help it come back from one state, say a La Nina state, back to neutral, and then to an El Nino state. And that sort of process takes anywhere between 3 to 7 years. So the one thing that we do know is that, whenever we're in a La Nina state or an El Nino state, it's not going to last because there's a lot of feedbacks that sort of pull it back to neutral conditions, and then eventually it'll move back into one of these extreme states. So, okay, well, why does this matter today? Well, so today there's not really a not La Nina right now. Some people might be like, oh, well, it's a very weak La Nina. I mean, technically, to be a La Nina, you have to have a certain size of temperature anomaly over a particular region of the Pacific, and it has to persist for at least 3 months. And yeah, we don't see that yet. It's possible that this very slight temperature anomaly, slight cold conditions, will, sort of officially become an ultra weak La Nina. But the fact is, though, that whatever this is, it's extremely weak. So this temperature pattern right here is usually a temperature pattern that is associated with La Nina. Generally, we see cooler than usual conditions around many parts of the globe during a La Nina. And if you compare that to the current November temperature forecast, for example, this looks nothing like the La Nina pattern. And so you might be wondering, like, okay, what is the point of this La Nina? Well, it's very weak. So it doesn't have that much impact. And so what this means is that there are other really critical factors that are driving this forecast for October, November, and December, and going forward. And so this is what we're going to hit on next. What are these other really critical factors that are creating this temperature forecast? So, in order to understand that, we're going to go back in time to about 10 years, to 2013. This was when a crazy sort of temperature blob, a huge blob of warm water appeared over over the North Pacific Ocean near the US West Coast, British Columbia, Alaska, and it just caused havoc. So, first of all, it altered weather patterns over North America substantially. It resulted in some drying conditions. It possibly brought on the super El Nino that followed in 2016. There's some good evidence from scientific research that suggests this, though I think that is not, not everybody accepts that, but I think there's some good evidence for that. And what we do know is that it just decimated billions of dollars worth of fisheries, as well as caused the die-off of huge ecosystems of birds and marine mammals. And so it had a major, major, major impact on so many elements of weather patterns over North America, as well as marine life within this region. And so, guess what? Today, you might be seeing this kind of interesting headline, The Blob Returns, right? And so you might be like, where is this blob? Well, this blob, the previous blob, it used to be kind of right here, that old school blob from 10 years ago. This current blob is a bit more west. It's enormous. This thing is 5,000 miles long. And here, what I'm showing is the December forecast. This thing is not going away. It is this, pretty large anomaly in the ocean temperatures over the North Pacific. And so, when you have anomalies like this, we usually expect it to have impacts on the atmospheric circulation. And in fact, when we look at our forecasts, that is exactly what we see. So here, what I show is an ocean field, or sorry, an atmospheric field that we usually use to understand the atmospheric circulation. And I have actually drawn some arrows here that sort of show what we expect the jet stream is going to look like. And in that case, essentially what this blob is doing is it's taking the atmospheric circulation and sort of pushing it northward over the Pacific Ocean. And because of that, it's really going to impact precipitation, particularly on the West Coast. Because of this, we actually think that California precipitation is not going to be favored over the next few months. And a lot of the precip is really going to come to, the Pacific Northwest, in particular in British Columbia. Furthermore, this sort of diversion of the atmospheric circulation is consistent with those very warm conditions that we saw over North America. It's really important to note that those warm conditions over North America, they don't mean that we're not going to have cold snaps. Remember, we are just totally primed for cold snaps right now. And we're primed for cold snaps very particularly because, as we mentioned, a couple of webinars ago, that particularly we have a negative phase of the QBO, and that negative phase of the QBO favors a weak polar vortex. So certainly, in terms of this background of warm conditions, we can definitely still expect cold snaps, just given the fundamentals. However, because of just this persistent blob that leads to kind of this circulation anomaly, we really believe that the kind of background conditions this winter will tend to be warmer than usual over North America. And finally, I want to hit on probably the most popular and well-known of ocean phenomena that affects the weather. And this is the AMOC, also known as maybe the thermohaline circulation or the ocean overturning circulation or the conveyor belt. And so what this thing is, it lives in the Atlantic Ocean. It moves heat in the ocean northward. And that movement of heat northward is incredibly important for maintaining warm conditions over Western Europe. This is basically the reason why England does not feel like Newfoundland. It is literally because of the circulation. If the circulation were to stop tomorrow, then the weather over Western Europe would change very significantly. Now, why are we talking about this right now? Well, there's interesting things going on with this circulation. And I just think that when we think about kind of the very long range weather outlook, it's important to keep things like this sort of in the back of our heads and to monitor them. So there has been a downward trend in the strength of this circulation since we started measuring it in situ in about 2004. And today, and in the forecast, what we see is just, evidence of what we think points to a weakening of this circulation. Now, does that mean Europe is suddenly going to dip into, a cold snap similar to what we saw in the day after tomorrow? Probably not, but it does have significant implications potentially for weather over Eurasia, South America, and Africa, since that is exactly where this circulation kind of delivers a ton of heat. And so we're going to continue to keep an eye on this because I think that potentially we may see some changes here in the future that will impact weather patterns. And so, when we think about long range weather, we really want to keep an eye on these very large scale features that potentially are changing and might impact weather. So finally, I want to conclude by giving a quick forecast retrospective of rainfall over South America, or sorry, South Asia. So a few weeks ago, I noted that there was some forecast convergence over South Asia. And this is actually a video that I showed at one of our webinars about 3 weeks ago. That was from a forecast that was generated 25 days ago. And in fact, we had even been seeing evidence of this in the previous week's forecast as well. So I think it's safe to say that these forecasts converged about 4 weeks ago. And what these forecasts really showed is just a lot of rain over South Asia. And this rain, very particularly, being linked to, first of all, a warm Tibetan plateau, and second of all, a phase two of the MJO. And the phase two of the MJO in particular, very predictable because the MJO is a very predictable mode. And on top of that, the Tibetan Plateau warming really favors a strong end of season monsoon. So when we see these factors that sort of converge together to give us a forecast, and we see many different models doing the same thing, that gives us a lot of confidence in the forecast. We think that the forecast is very robust. And so, unfortunately, this has come to pass. There are some pretty devastating headlines in the papers right now about flooding, landslides, and lives lost over the past week in terms of these kinds of heavy rains. And so, once again, I mean, long range forecasting can be really powerful. And I really look forward to the day where we are able to deploy these types of forecasts better so that we can really help communities and households prepare for what is to come and, can really help build some resilience on our planet. So thank you so much, everyone, for being here. I'm really excited also to mention next week's webinar. In fact, if you go to our website, you can see the list of upcoming webinars over the next few weeks. Next week's webinar in particular is going to focus on supply chains, the impacts of long-range weather on supply chains. I'm going to be joined by guest Sadie Frank, who is CEO of N4EA, where they do a ton of computational modeling of supply chains in particular. And of course, if you're interested in the modeling that we do, please feel free to contact me. My email is hansi@planette.ai. You can also follow me on LinkedIn, where I tend to post frequently, specifically on the intersection between finance, climate change, and weather, and what that means for various elements of your portfolio. So thank you so much. And now I would love to open the floor to any questions that folks have. Thank you. If you have questions, you can feel free to put them in the chat, or if you want to unmute yourself, feel free to do that as well. We would love to hear from you.
I have a quick question, Hansi. Well, first of all, thanks for presentation. It's helpful for the midterm to long-term view over the winters. Do you have any thing? Well, you did say that there would be some cold snaps
Oh,
despite your
yes.
prediction of like a warmer, relatively warmer winter. Do you
Yep.
think those snaps would be more like a North America focused or more like a European focused?
Yeah, so when we see weakening of the polar stratospheric vortex, and by the way, we actually have our stratospheric expert here, so he will jump in if there's
Mhm.
anything to add here. But in particular, when we see conditions that favor a weaker polar vortex, we can usually see that sort of vortex breakdown happening a few weeks before the cold snap hits. Now, just keep in mind that, when the cold snap hits, it tends to be over Eurasia. Eurasia is sort of the first preference for cold snaps. But one thing that I will say is sort of looking at this particular, circulation pattern. I would actually say that this potentially, if there was a cold snap, definitely keep an eye on Eurasia and particularly Siberia, Russia, the North Shore here, particularly in terms of Scandinavia. But this sort of circulation pattern, I mean, you could imagine it, creating a cold snap over the US as well. So generally, you would say it's definitely favored over Europe, but we see these cold snaps all the time over the US. And once again, whenever they're sort of led by the stratosphere, we have a good deal of predictive power for, being able to anticipate them a few weeks in advance.
Thanks. That's very helpful. Yeah.
You're welcome, Dheeraj. Well, thank you all so much. I don't hear any other questions. I'll hang around here for a little while if anyone wants to have kind of an informal conversation. But yeah, thank you so much for being here. The recording for this webinar will be available on our YouTube channel. And yeah, we're really excited to hopefully see you at future webinars and yeah, stay in touch. Thank you so much.
I can ask one more. Can
Oh
you
yeah, of course.
educate a little bit more about like how does like MJO interacts with El Nino or La Nina? Oh,
Aiden, do you want to take that
uh,
question?
Yeah, nice to see everybody. My name is Aiden. I am one of the scientists here at Planette AI. I'll caveat this with saying that I'm not a huge expert in the MJO, or excuse me, the ENSO influence on the MJO. However, typically when we see the strongest MJO activity, we're seeing that MJO over the Western Pacific. So if you look on the map that Hansi's showing right now, this would be near like Indonesia, and this is actually some of the warmest surface temperature anomalies on the planet. During La Nina, warmer temperatures are typically seen in this region. And because of that, that means that the convection is even further enhanced. So you would expect on first order that the MJO and that the, La Ninas and positive MJOs would constructively interfere to create even larger connection in that region, and thus also have stronger extratropical teleconnections, which are these influences on northern hemisphere weather and southern hemisphere weather very far away from the tropics, which are really driven by these changes in the circulation due to the MJO and ENSO influences.
Yeah, and I think related to that too, I mean, we're seeing such a little piddly, not La Nina, right? So, I mean, that's kind of interesting too, because if anything, we might expect that because the MJO is especially strong now because of the negative phase of the QBO, that, we might see some enhancement of that La Nina signal, but we just don't. Like, it's not really, yeah, go
Yeah,
ahead.
I just wanted to chime in and say, yeah, this is something that we didn't hit on today. But if you want to understand about the interannual or the year-to-year variability in the strength of the MJO, and thus how much predictability you can get from its signal, the strongest determination isn't actually ENSO. It's really what's going on in the stratosphere, or at least for the boreal winter MJO, which is typically when we see the strongest MJO activity. So when we're talking about a negative QBO phase, that means that we have easterly winds 20 kilometers above the tropics. That means that we're generally going to have a stronger MJO that year, and that's actually what we're seeing right now. So regardless of what's going on with ENSO, we would actually expect stronger MJO activity this year just because of the stratospheric preconditioning.
And Dheeraj, if you want to learn a bit more about that stratospheric preconditioning, the Cold Snaps webinar that is on our YouTube channel is really useful for understanding that because I know that we probably just said a huge alphabet soup of various phenomena right now, and it might be hard to follow, but I think that webinar explains it. And of course, I'm happy to chat with you further about it as well.
That's great. I'll follow up your channel on YouTube and look into it. Very helpful, guys. Thank you very much.
Yeah, thank you. Okay. Well, I think we will go ahead and say thank you. Feel free also to connect on LinkedIn if you have any further questions that come up over the course of the day. And yeah, just really excited to stay in touch and be able to tell you about the long range weather every week. So yeah, great to see you. Thank you all.